Welcome to another teardown and test video. This time it is an ELBRO EFT 2040. This one was designed in 1991 and the last unit was sold in 2001. So that means today this is 21 years old, this unit at least. I just plugged in a brand new 9-volt battery and it says 19.3. In here I have another sensor that is a factor of 10 more accurate. I put those two sensors in here and they have been here for an hour, or actually quite a lot more. So I will have the temperature. Here is 20.67 something. So this is what it reads, and this is the actual temperature. So that means a little bit more than 1 Celsius in error. Here is the user manual for the ELBRO EFT 2040. Sorry, but this is in German, and I'm just gonna scroll through this so we have everything together. So about the data sheet, it says this is resolution 1 Celsius. That is not really true because the resolution is 0.1 on the display. So I think there is something wrong with this manual, or maybe this was a very early version of the manual. This means accuracy. So the accuracy is plus minus 0.8. So that is, I think it is very, very close to be within spec. I don't know anything about relative humidity. I don't have anything to calibrate that with. But yeah, that was the most important thing from the manual. Here it says a little bit about how to use it. I think the text on the unit explains exactly what is what. And yeah, there will be a bat on the display when the battery is flat, and then you need to replace that. And again, 1991. And remember, we also saw 91 on the PCB. So here is how this fantastic sensor looks like. It measures both humidity and temperature. I guess this little one here is the temperature. And see? So this is the humidity and the temperature, and it will also display the temperature in Fahrenheit. Really nice. I also like the hold feature. If there is a temperature you need to remember and then do something else. Let's tear this down, see what is inside. I was hoping to maybe find a trimmer so I could calibrate this and make it read correct again. But look at this. It is in mint condition. Somebody did really take good care of this. I see 4 screws, so it should be fairly easy to get in. There is one thing I find a little bit funny. It is this text: electrical shock. Remove inputs. How do you remove inputs? So I guess this case, or just the text warning service contains no. Yeah, so maybe this was from another or a voltmeter. They just took the plastic or the text from a standard voltmeter, where you could of course get electrical shock. Also the battery compartment. There's a screw here. Of course I got the screw as well. So anyway, let's open this thing and see what is inside. I didn't expect that to be so difficult, but it surely was. Ooh, look at that. That is really, really beautiful. And what have we got here? This is exactly what I was waiting for. Wow, the trimmers. And if I just used my brains and eyes a little bit, I could have accessed the trimmers from outside. And this is exactly what they said in this text, that I don't need to go inside to service this. Haha! All the trimmers, they're down here. But it only says trimmer this and trimmer that. It doesn't say which one is temperature and humidity, and I don't want to screw up the humidity. Maybe I have an idea. Maybe I can just touch the trimmers or something before I turn them, so I can figure out which one is doing what. Or maybe I can follow the switches. Let's see, what have we got here? What is that? 555. Aha, so this is the oscillator. For what? That is interesting. And down here, oh, we got some more ICs. Ooh, we got a big one. So this is the display, or the analog to digital conversion and readout chip. And the display is in a socket. This is really nice. And then they glued it here so it's not gonna fall away or something like that. Maybe we can take out the PCB. Maybe there's, oh yeah, see? So this is the back side, and here's the magic capacitor that will save the day for whatever reason. And all the wires for the sensors. It is a little bit funny with this cable. It is really, really thick and kind of stiff. Maybe it was a little bit more soft and bendy when it was new. Have you seen this one before? So this is a 79L05. That means it's a negative voltage regulator. And see what they've done? They're regulating still. See? The minus input goes to the middle. So they're regulating in the negative. Oh, that is so funny. Why would you do that? Well, just because you can. It really doesn't matter if you regulate in the positive or in the negative. Ha! That's super funny. Anyway, I will see if I can start figuring out the trimming. What this can do. It says something here. Wow, 200491. Exactly. And also about this text, of course I found out. If you look at the case, of course they're reusing the case. Look at this. Maybe voltmeter inputs, right? And some other switches and stuff. And you can also take this off and have inputs and outputs here. So of course you only make this case once and then you reuse it for a lot of different meters. So there will also be some other things here in the plastic where you can stick in something. This is maybe for measuring capacitors or something like that. Then you will stick in the components into this area. So of course they're reusing the case is actually quite nice. And here there could be a beeper or something. Yeah. So that explains the funny text. So here is what I came up with. I took a 10K resistor and then I played with the different trimmers just by adding 10K to the pads and see what happens. If it goes up or if it goes down. It's difficult to touch, see? So this one manipulates the temperature readout. So now I am in Fahrenheit. If I put it back to Celsius, the two first, they change the temperature. One is of course gain and the other one is 0. I really don't know how to figure that out, which one to touch, because I'm a little bit afraid if I touch the wrong one, I can make it read the correct temperature, but then if I change the temperature, then I will maybe have an even bigger defect if it is the gain that I manipulate. So that is a problem, how to figure out what is the gain and what is the 0 or the offset or gain, right? So that is a problem. This one is only affecting the Fahrenheit readout. So this is Fahrenheit gain or Fahrenheit offset, obviously. So this one I don't want to touch because I have no idea about Fahrenheit. So I'm not going to use that one anyway. And the last two ones, that is those are humidity. But again, I don't know which one is gain and which one is offset. So I don't touch those. So it's only the two first I need to play with. So I need to write down the values and then manipulate with a known resistor and then heat up or cool down the sensor and manipulate again and then see the difference. This way I can figure out which one to trim. So it's not that easy, is it? But I think that was what I wanted to show with this video. I hope you enjoyed it. See ya! I also wanted to figure out what is inside this one. I just had the idea that it was only the wires connected directly to a temperature and a humidity probe. But they always hide screws behind tape or something. So I don't know exactly how to get this off. But there's actually a PCB in here. Look at that. And components. What the heck? In the probe? Really? That is pretty cool. Alright, I need to figure out how to get this off. Alright, let's have a look at this circuitry. This is a 555 timer oscillator. And the humidity sensor is a Philips H1. So this means it is variable capacity with humidity. And if you search on the internet about Philips H1, you will find a lot of circuits explaining how to use a 555 as a variable oscillator to read this sensor. Really smart, and this is how they did it. And the temperature probe is just connected to the other pin out here. Yeah, but that is what was inside the probe. A lot more than I expected. And this one locks in by turning. Click. So now I can put it all together and see if I can figure out how to calibrate this thing.